Hey everyone, Houston Math Prep here. We're going to work through our first example of getting a surface of revolution. So we're going to find the surface area of revolution if we take a piece of y equals x cubed, particularly on the interval 0 to 1 for x, revolving that about the x-axis. You can see here from our animation, this is the type of surface that we would get. So we've got our surface area formula here, 2 pi integral function times the root 1 plus the derivative of the function squared, dx. Since I'm revolving about the x-axis, we will use dx. Remember, your dx or dy will match the axis of revolution that you're doing. So the first thing I need to do is generate a derivative so I can start building this expression here. So if my function f of x is x cubed, then the derivative of that function, which would be just a power rule since we have x cubed, would be 3x squared. In our formula here, remember that you need to actually square your derivative. So if I take my derivative and I square it, 3x squared times 3x squared is going to give us 9x to the fourth. So if I start building this, based on the actual function that I have, 2 pi will be outside my integral just as a constant multiple. A to b will be my x bounds here since I'm integrating dx, so that's from 0 to 1. My function will go on the outside, so the original function was x cubed. And then we'll have our square root, which has a 1 plus, and then we have f prime of x squared, which was our 9x to the fourth in this example here, dx. And so we'll go ahead and continue working that integral now from here on out. So in order to do this antiderivative, we might see that we have something with an x to the 4 term underneath the radical. We have an x cubed outside of the radical. So a good substitution here would be a u substitution where u is everything underneath the root, so 1 plus 9x to the 4 being u. And then the derivative of this will give us some sort of x cubed term. So derivative of 1 is 0. Power rule here, the 4 comes out and multiplies the 9. We get that du is 36x cubed dx. Okay, so if we now think about what's going on, we have everything under the root is going to be u, and then what I have outside of the root is x cubed dx, which I don't have exactly, but I could solve for x cubed dx, figure out what I'm replacing x cubed dx with by dividing both sides by 36 in my du equation. And now you can see that x cubed dx is going to be replaced with 1 over 36 du. Okay, we'll go ahead and make that replacement. We'll do it over here, so we're going to get 2 pi integral from, now we're replacing x's with u's, so remember these are x bounds, x equals 0 to x equals 1. You can solve new u bounds if you would like at this point in time. I'm just going to leave our bounds in terms of x. So remember that my x cubed dx was du. We'll put the du at the end, but I did get over 36, so I'm going to go ahead and bump my 1 over 36 out, and we'll simplify that in a second. We get the square root of u, and we said our du will go there. So we'll need to do some reducing here. So I have 2 over 36. I'm going to go ahead and make that pi over 18. And then I have the integral of square root u. So I'm going to go ahead and think of that as, again, keeping these as x bounds. To make it a little more obvious what we're going to do here, I'm going to change that to u to the 1/2, right? Square root is the 1/2 power. So we'll have the integral of u to the 1/2 du, and now it's a power rule. So moving down here, we'll do the antiderivative now. I'll keep my pi over 18, and I will get power rule. I will add 1, so I will get u to the 3/2. We would say divide by the new power 3/2, but instead of dividing by a fraction, I'm going to multiply by the reciprocal, so I'm going to multiply by 2/3 instead of dividing by 3/2. Remember that these are still x bounds, 0 to 1. And now all I'm going to do is simplify out front and replace my u's in terms of x's so I can plug in my bounds. So if I reduce 2 over 18, then that would become a 1, and that would become a 9. And multiplying the 9 with the 3, I'll get pi over 27. And then replacing u with my original substitution, I will have 1 plus 9x to the 4th to the 3 halves. And now that I'm in terms of x, I can simply write these as 0 and 1. Okay, let's do our plugging in. So we will get pi over 27. Plugging in 1, I would get 1 to the 4th, which would be 1. And 9 times that would be 9. So 1 plus 9 will give me 10 to the 3 halves. Be careful here. When I plug in 0, I don't just get nothing. I get 0 for this term, but I have 1 plus that term. So this is actually 1 to the 3 halves. I could write 1 to the 3 halves, but any power of 1 is just going to give us 1. So we'll get that there. And then I may want to rewrite this 10 to the 3 halves term. Remember, the half power is going to be the square root. And then to the 3rd would mean cubed. So I have the square root of 10 cubed here. In other words, I have 3 copies of square root 10 there. And what we may want to do is take 2 of those copies and rewrite it as a single 10. So we'll go ahead and say pi over 27. We'll call that 10 times root 10, or 10 to the 3 halves, minus 1. And because this was a surface area, any type of area, we are going to want to write whatever units were given or not given. So here we'll have pi over 27 times the quantity 10 root 10 minus 1 units squared. We have 2 more of these surface areas of revolution example videos. Check out the other 2. We'll see you next time.